Today we're going to go over the solutions to the finite distribution project that we did in class, if you're on the on-campus class. And what we're doing is we're taking this Excel spreadsheet and we want to complete this. And in the process we're going to go over some of the things that make up a finite distribution. And you may notice that I've actually put this as a single page within a larger document that's called finite probability distributions, and we're just looking at this one defined by table. So let's go ahead and finish this out. The idea here is that the user will enter some values here in increasing order. Okay, in fact let's say that here for the person. Values the random variable in column B in increasing order, and the corresponding values of the PDF in the other. So column there. Okay, and so the spreadsheet will show all of the work. Okay, so let's work this out. You put probabilities here. Now they should add up to 1. And I have this spreadsheet going down to this black line down here at so through row 108, so that I can go up to 100 different values for x. So hopefully that will be all I will ever need. So the first thing I need to do is add up everything in this column. And of course if it's not 1, then we don't have a legitimate probability distribution. And the easiest way to do that is just hit this sum button up here. It looks like a sigma. Or if you remember, just write equals sum, close open parentheses, and in the parentheses we just highlight the cells like this that we want to include. To here, hit enter, and if you'll look, that does sum up to 1. If I click on this cell right here, which is cell C5, the way I've got it set up here, that says to sum from C8 to C108. Now notice what happens when I copy that and I go over here. I don't want to mess up my shading, so I'm going to go to paste, and I'm just going to paste the formula. And now this says sum E8 to E108. So notice it does that relative referencing. So if I paste this over here, copy this and paste it here and here. Okay. Now let's see what we have here. So now this is summing to 1. Notice if I put a new number down here, 0.1, now it doesn't sum up to 0.1 anymore. Okay, so of course if I'm going to use this, the values of the PDF have to sum to 1. So this 0.1 is actually the PDF of 2, which means it is the probability that x equals 2, and the probability that x equals 5 is 0.05, and so forth. And I can change these numbers to whatever I want as long as it sums up to 1. I have a legitimate PDF. Now the CDF is the cumulative probability. Now it's important we have these in increasing order, and so that first one will just equal this cell to the left, equals cell C8. And then the next one I can get by adding this one above plus the one to the left. So that's D8 plus C9. Notice I was able to, instead of just typing in D8 and C9, I was able to just click on the cells. Now I can copy this, either do it two ways, Control C and Control V to paste, but I can also drag the corner down, and I want to copy this all the way down. So I could have copied it, highlighted all these cells and pasted, or just drag it down. And notice that it does relative referencing. So every time it is the cell above plus the cell to the left. So that means it's the sum up to that point, the cumulative sum. So for example, this 0.25 I get by adding the 0.15 and the 0.1, but ultimately it's the same as adding all the points, all the values of the PDF up to that point. So this 0.25 is the probability that x is less than or equal to the 7 over here. And of course once we get up to 1, it stays there from there on out. Now the way this spreadsheet is set up, we're going to have values all the way down, except maybe for in the blue column. So we'll have values completely, actually we'll have formulas put in all the way down to here filling out the spreadsheet, but they will have, there'll be values when it evaluates it. But the good news is for anything below where we have the data value, on the columns I really need to sum up, the ones that are not grayed out, that will all be zeros, and so that will not affect our computations, which is good news. Now to find the mean, what we do is we take the x value times its probability, which is there, and again we want to copy that and paste it all the way down here. I can do that by just dragging the corner down. It's probably the easiest way to do that. And it multiplies those probabilities. Let's just check it out. 2 times 0.1 is 0.2, 5 times 0.05 is 0.25, and so forth. And notice it did those. Then what it does up here is it sums those up. I'm going to make that show 4 decimal places. And there's the mean. Okay. Next, let's find, and of course the mean, so the mean is just the sum of x times the probability of x. That's mu. You know what? I'm going to actually put the formula in here. We'll go to math type here. Mu equals expected value of x equals the sum over all x of x times the PDF of x, the probability of x. Okay? And I'm going to copy that and put it right over here in the spreadsheet, right there. So there's the actual formula for the mean, and that's what we were doing to find it. Now, let's find the deviations from the mean. So, because as you know, the mean is a measure of central tendency. Okay? So now let's find the deviations from the mean, x minus the mean. So we do that, we take the x value and subtract the mean. Now look what happens if I copy and paste down below. It's when I copied and paste, then notice this is saying go 1, 2, 3, 4 cells to the left, and subtract from that 1, 2, 3 up and 1 to the left. So this is subtracting the 5 minus, well, whatever's in that cell. That's not good. We want it to be specifically that cell. So if you want a cell reference to not change, or part of a cell reference to not change whenever you copy and paste, you need to put a $sign in front of that part. So if we don't want column E to change on this one, we put a $sign in front of the E. If we don't want the 5 to change, we put a $sign in front of that. So now when I copy this and paste it below, now notice it stays E5. It switched from B8 to B9. Okay, so now I can paste that down. I'm actually going to copy this in a minute. I'm going to copy this whole row and paste it down. So I'll do all my pasting in a minute, all the way down. Now, if we take those deviations from the mean, and we multiply them by their weights, their probabilities, we get this. And if we add those up, it'll always add up to 0. Now, like I said, eventually I need to get this all the way down to the bottom of my spreadsheet, which I will in a minute. Now, what do we do? So that's just an interpretation of what the mean is, but that's a little check for us. Okay, now how do we actually compute the variance? Well, the variance is the expected value of x minus mu squared. So what we do is we need to take x minus the mean, these deviations from the mean, and square them. Okay, and this is exactly how we did the variance back in the data case where it was just a population data. In fact, there's really not much difference between a finite distribution and an actual set of data, where this is the relative frequency, is the probability. So we take each one of those, and we take each one of those values, the squares of the differences, and multiply by the weights by the probability. Okay? And now we want to take those and then add those up, and that'll be the variance. The standard deviation is, notice the formula, the square root of the variance. Okay? So let's go ahead and, well, we'll copy it down in a minute. Okay, and then, now, we can also measure the skewness. Okay, so let's back up a minute. The mean, remember, is our most standard measure of central tendency. The variance, or its standard deviation, is our most standard measure of variability, or spread of our distribution. And skewness has to do with symmetry. So a zero skewness means it's completely symmetric about the mean. A positive skewness means there's more kind of clumped up on the left, but the tail is extending out to the right. And a negative skewness is the other way around. There's more clumped up near the mean on the right, and the longer tail is to the left. Okay, so what we need to do is we need to find differences for the mean, but we need it to an odd power. And of course, the first power we see didn't work, so we're going to do a third power. But we're going to basically take out the just as we took out the mean here, and we're going to look at we're going to weight this by taking out the standard deviation. So basically, what we're going to do is we're going to figure a z-score for each point. And remember, a z-score tells how many standard deviations you're above or below the mean. So again, we start formula with equals, and we want to take these differences from the mean and divide them by this standard deviation. Now again, this standard deviation is a specific cell, so we want to put dollar signs in front of that so that when I copy that and paste it down below, it's going to give us what we want. Now we take each one of those z-scores and cube it. Okay, Shift 6 is the power key. And then we take that z-score cubed times the probability over here, and then we'll add those up. So now if I copy, I should be able to actually copy all of this right here, and then go all the way down here and paste. So I just copied that. Control C is copy in Windows, and then Control V is paste. And so now I have my values running all the way down. Notice that the ones I'm summing up, this one, this one, this one, and this one all have zeros down past where our data is. So it doesn't affect anything. And so now we have our spreadsheet set up. Let me go ahead and put those other formulas in there while I'm at it. Okay, so we put another formula for the variance, which is sigma square, and that's the expected value of parentheses x minus mu square. So you should remember this from your earlier thing. Okay, so what do? We sum up for all x values, for all possible values of x. What are we summing up? Well, we're summing up, well, this expression here times the probability, that is the PDF, of x. So we're summing up all of that, all those products. Okay, and let's copy that and put that formula right here, somewhere in here. Let's put it right in here on the spreadsheet. Maybe I need just a little more space just for these formulas. So let's do this. And of course the standard deviation is the square root of that. sigma equals square root of sigma square. And so there's the variance and standard deviation. Okay, so we have the formula there. And the formula for skewness is the expected value of the z-score. Okay, so it's x minus mu over sigma. And then we cube it. So we take that part right here, times the probability and sum it up for all x's, and that's the skewness. So there are the formulas for the mean, variance, standard deviation, and skewness. And we have our spreadsheet that will now work this out. So now I should be able to change my numbers here, for example, and this will figure out everything. So I just put some numbers in order: 2, 8, 11, 14, 17, and 22. And let's format this the same. Let's see. Okay, and now we put in some probabilities. 0.1, 0.3, 0.02, 0.15, I got a little bit, 0.08, 0.3, and that means the last one has to be 0.07 if I'm going to get them to add up to be 1. So there we have some probabilities associated with these things. And notice how everything is working out. Now you may look at this and you say, well, that's not 0. Well, practically it is. It goes from its point and then 14 zeros and a 1. If I work this out to 2 decimal places, that certainly is 0. In fact, I want to kind of set these just to show, let's say 4 decimal places. Well, maybe we'll go a few more. Okay, 6. So there we go. We have our thing. Now, suppose I want to graph this PDF. Well, I can't really graph this in Excel very well. I can make a bar graph, but then these won't be spaced out correctly. So what we're going to have to do is just make a scatter plot of the data. So highlight the data that you want to plot, and actually for the PDF I can highlight all the way down here. If there's no data, it's not going to hurt us. And then go to Insert up here and click on Scatter Plot. Just use this first one. Notice we have a dot for each point. Now when you actually graph the PDF, these would actually be bars. These are the center of the tops of the bars, and the bars would come down to the graph. We actually get all the same information right here from the dot, from this kind of a plot where we're just plotting those dots. We don't need that, so we're going to format this a little bit. We can click on Layout here, and we can adjust some things here, like turn off that legend. We can add axes titles. The vertical one, we could maybe rotate it this way and say probability. Like that. We could maybe look at the bottom one, and like this, and then maybe call it values of x. We might click on the axis here and say format it, and tell it to always start at 0 and always go up to 1, and always mark it off in tenths, no matter what. Maybe I could even go over here and make that bold. Maybe if I'm going to do that, I probably want to make that one bold. I might want to go back here in the layout and turn on some vertical grid lines as well. I definitely want a title. So how about above the chart here, and I could graph this, the finite distribution probability density function. That is the PDF. Okay, maybe that's too big, so I might come back here and make this 14. Let's make it even smaller. 13 ought to do. Let me see if I can. Should be able to make this where it doesn't wrap around so much. Let's see here. About 12. That ought to work. Okay. And notice I can move it around a little bit. I can click on this part and make it go up or down or in or out a bit. I can click on the back part of this here and say format the chart area. Say I want to fill it in with some nice color there, and now we have a graph. I'd already done something similar to that over here, so let's go ahead and look at what I've got here, and we see our graph there of the PDF. Okay, and so we get a pretty good idea what this graph is going to look like, what the function is going to look like. And so that completes that particular spreadsheet. And of course, hopefully yours will be the same. I can change this, and notice everything is going to be dynamically figured out because it was all done with formulas. Now notice also that this is part of a larger spreadsheet here that I'm going to be posting here. And this goes over some of the things that we have talked about already and some that we will be talking about in the future. This goes over some basic counting arguments and figures out the values of these things if you just change n and k. And it works out what these things are. Here goes over some probabilities associated with the birthday problem. And then we're going to talk about, from here on in our subsequent sections in this unit, we're going to talk about some basic distributions. And the way these basic distributions work, I have the graph of the PDF, and this I was actually able to get it to work out to be an actual bar graph this time. And the CDF, however, I can't get it to really do the right thing. What I can do is, this should be a step function, so it's 0 to the left here, then it stays here and goes over, and it steps up here and goes over. And but anyway, the way these work, the number in red there and with the blue background is what you change, and that's the parameter that defines the specific distribution within this family of distributions. And it figures out all this information here, including the PDF and CDF table, and some parameters, the mean, variance, standard deviation, and skewness. Talks about the binomial distribution here, which is a very important one. This one talks about the binomial distribution if you just have certain, you just put in n and p and it figures out some of the parameters, so we can do those by to compare. And so we have sort of a binomial probability calculator over here. Hypergeometric is similar to the binomial, but it's done without replacement, whereas the binomial is done with replacement. This compares the binomial, the hypergeometric, and a normal distribution, which is something we'll talk about in our unit down the road. And this talks about the geometric and the negative binomial and the Poisson. So those are the main finite or not all finite, but all discrete distributions that we'll be looking at. But of course this one deals with just a finite distribution, any finite distribution, if you can actually type up the whole table, which you should be able to do here if it has 100 values or less. And we can use this to compute the parameters there.